Good evening, folks. It's good to see everybody online again here this week, which is week 6 for us. And on the screen here, you can see that we are in week 6, inching ever so closely to week 8. So we'll just have a couple of weeks left. So, as a friendly reminder, we do want to encourage you to be thinking again about your final projects. I'll try to be building in a lot of class time next week, which will be week 7 for us to talk and discuss your final projects and what that might look like and how I can help you in the week remaining. So if anybody does happen to have an idea that they may want to use the total station or something like that, please let me know so that I can bring that up with me next week, Tuesday there. So keep that in mind if there are any gadgets or gear that you might need. And they could just be regular GPS units as well. So I do have some of those units as well. We didn't use them for the course this year because we wanted to move into more of the app collector constructs there. So if you do have a need or want to use a handheld GPS, let me know and I can be sure to bring those up for you to share. So, welcome to week 6. And as you'll see in the overview, excuse me, our overview session here, we'll be dealing with a continuation of really our mobile GPS lab that we did last week, working with Collector. Except this week, we'll be working with something a little bit more streamlined, and you'll see that the second bullet streamlined with dealing with utility collection and assessment. And you'll see that bullet number 2 here was IoT, or the Internet of Things data and sensory concepts. Just to give everybody a briefing, uh, in the announcement that I distributed the other night about our assignment, there were some slight modifications. The original plan was to have sensory data and gadgets provided to everyone. Although, you recall from our week 2 there where we got together, the the ability to purchase or secure those data sensors were that it wasn't was not approved. So we unfortunately weren't able to get you all of the data sensors to use for the course. So as a result, I'm building the another application for ArcGIS Collector in uh, for this particular period, dealing with utility application assessments. So it's really more of a scenario, and we'll break that down here shortly. So a scenario that you could mimic either at work or on the job type of a thing as well. So we'll be capturing some utilities, part of our lab, and the idea and the goal otherwise is to really flank our IoT concepts. There are some really cool, I think, pretty well done videos. Some are pretty short, and others are more application oriented, where you can see how IoT and GIS are really integrating together to make a more robust platform of analytics. And so we'll show you those here in just a minute. And then that aspect is really flanking our continuation of our ArcGIS collector application that we'll be getting some more exposure and experience to. So let's go ahead and take a look here at some of the general class content. Most of the material that you're seeing here will be some short readings and then some really, I think, interactive mapping applications, in particular with the first link right there, the Learn ArcGIS. And not that this all has to be around ArcGIS, but I want you to see some applications that are really kind of prepackaged and put together for us, that you can see how IoT works. And as I mentioned, the premise would have been really cool if we would have been approved to, pick up the sensory data kits that I was hoping to use for this course, but alas, it did not happen this year for us, sadly. But hopefully in the future we can do that. So there's a lot of really neat information in here. And the geospatial analysis and Internet of Things is a research paper, so pretty well done, exploring all the ins and outs of IoT and integration of geoanalytics with that. So there are a few short videos here. Really, the first one is a shorter one here, looking at IoT and GIS, really bridging the gap on how we're able to make GIS a little bit more effective based on some of our input data sets. So a lot of this course is trying to figure out where our data sets are coming from, and some of it we're collecting. A few of the periods we're collecting that data ourselves to give you an appreciation for that. And for this particular week, it's thinking about IoT sources. So even if you have data sources at home or tapping into online weather systems or whatever it may be, there's a lot of sensory data that's being placed out there on the web that you might be able to get your hands on. So whether you're looking at sample tracking information, GPS information, weather stations, camera, street cameras, things like that, you may be able to patch in and collect data like that yourself. Not yourself, but take that data that other sensors are providing and then harness that data and start to make sense out of it and or just analyze it, explore it, look at it. So you do not necessarily need to go out and physically capture all the data in this course for your final class project or anything like that. Instead, you could have devices or utilizing some other framework of data collection and then making sense out of that and packaging it up to analyze, what that data is saying or suggesting, perhaps by way of patterns, or maybe it's something unique in terms of a trend or something like that that you might be able to see. So largely just keeping your mind open to being creative for sensors and how we can use that in a geospatial context. So the first video discusses a little bit of that, and obviously, we'll have a welcome video here that we're recording, and then I'll be taking you through a short little demonstration of what the lab will be about, similarly to last week. The second video here is more of an integrated application. So it's think of it as a webinar where the presenters are taking you through some real data from sensors and integrating it, showing you how that data is almost in effect real time being used to make decisions. So I know some of you in the course have access to sensory based data either through cellular cell tower communications or tracking different things. So these are great examples of IoT based mobile devices or IoT devices that you are using to make spatial decisions off of, or evidence in some cases. So uh, that type of a flavor drops in nicely with some of this. There's a few short videos here on geospatial technology, and kind of the new buzz is learning about this industrial revolution, the new fourth industrial revolution of how whether it's 5G or all these aspects of IoT are bringing in AI and bringing in a completely new landscape of how we can look at data and explore data and understand it in new ways. So the last short little video here, I think this is just a couple minutes as well, is just looking at IoT locational intelligence. A little bit of a spice up there from ESRI, but nevertheless, it'll give you another example of how kind of the sensory-based data platform are making our lives ideally more beneficial, but sometimes more complicated and complex as well, provided we don't have a purpose. If we have a purpose for everything, that should dictate what type of data we need and how much of it we need based upon, again, our purpose. So the last little video out here, the YouTube video, is relating a little bit more to our lab. Again, not directly, but instead looking at how can we incorporate different high accuracy data collection. And I'm working with one of our presenters for next week to talk about how, for example, Trimble, maybe not so much getting into the software anymore. They've realized that their specialty is really about high-end, super accurate antennas. And so working on the communication between those antennas with other mobile devices such as ArcGIS Collector and other mobile applications that are out there. So this is really a short little 30-minute workshop on kind of the outline of how that stuff works for improving high accuracy data collection. Then we'll talk about our activity assignment number 6 here as well. So it should be a little bit more streamlined, a little bit more straightforward than last week, but also it should give you a lot more creativity to explore data and present that in the manner of your choice. So a lot of these assignments, I have debated whether or not to provide example labs or example write-ups, or this is exactly what it should look like, because I feel it takes a little bit away from your creativity in that aspect. But instead trying to steer you down a path from which it gives you that option for how you would like to share your story and share and explore some of your data and your findings ultimately and what you learned. So we'll break that down here as well, but did want to make sure I addressed the the lab guides again for iOS and Android here. So some of that'll be again very similar to last week, but we'll go through that here in the second video. And then there is a zip folder out here that I provided. And the only thing that we will not see on here yet, so I want to check a few other things out here before posting the short little quiz for this week. So again, a little 4-point quiz that does not appear on here, but we'll get that loaded here towards the tail end of the week. So let's go ahead and explore and take a brief look at the agenda for week 6. And I already have that pulled up. So very brief agenda, but we kind of went through everything here. The materials on Blackboard that are provided and the activity assignment we'll talk about, the 4-point quiz we addressed. So let's go ahead and briefly break down the activity assignment number 6 for you. And then again, I'll follow up this session with another session on how that might look if we were to demo that out. So the idea behind this assignment, again, it was modified there based upon some of our inability to get some of our data sensors. And so instead, what we're looking at here is still a continuation of mobile data, sensors on our phone, devices, in that aspect, but looking at really a scenario that focuses on utility mapping and assessment. And in some past courses, we did things that are a little bit related to this. In other words, if we were to send out a team of people to go collect data, part of the lab was in the past going out and having everybody collect some of the same points. And then when we bring those points back in, we understand how not necessarily physically different people interpreted these points, but how really in a characteristic type of fashion, people were calling light poles a certain condition and fire hydrants in another. So what you ended up with is a lot of really inconsistent data. And part of the goal in that experience was to highlight when you're going out and collecting data as a team of individuals or a team of people, we want to try to create and create consistency in our data collection process, which is super important so that our data becomes more valid and easier to use, so less problematic. So this is also a great way when we a great way, meaning when we standardize our data or when we provide training options or training standardization, this provides a much clearer path to data validity by way of suppressing data collector bias. So, it doesn't mean that somebody's intentionally trying to create data in a bad way. It's just that their interpretation of features can be different from that of another person. So we'll be piggybacking a little bit on that, but instead doing an assessment scenario of taking a look at utility features in a study area of your choice. This could be a the block that you live in, not the block group, but the physical, like a community block that you live in, or it could be like a park or some other area that would have some assortment of signs or storm drains, light poles, or street signs. And so we have a number of these features already pre-programmed for you in the mapping application that we'll be unveiling here for you this week. But the goal ultimately, I'm just looking at this paragraph right here, is to conduct a utility condition assessments of features that you collect in an area of your choice. So again, the area does not need to be large, but I think it should contain a decent number of utility features that you can collect. So for example, all we'll be using the app for will be to go out and collect the physical locations, just the XY locations of our utility features. So if you happen to find a street sign, you'll record that location, document its condition, maybe take a photo of that, and then upload that. So once again, just like what we did last week, we'll need ideally cellular connectivity and the ability to have access to the new collector app. So I think everybody should be okay in that. So I think we're all up to speed with that. But when we're conducting this lab, see if you can find like a minimum of 5 to 10 points for each type of feature. So, for example, we will have fire hydrants. See if you can find 5 or 10, or better yet, see if you can collect all of those fire hydrants within your study area. Another one will be street or lights. Street lights or just plain old access lighting or something like light poles, whatever. So again, we're looking for 5 to 10 of those points minimum. And then storm drains. So they could be gutter drains or other utility covers that you see in a particular area. So see if you can identify and record at least 5 to 10 of those in your study area if they exist. They may not exist. If they do not exist, obviously you're not going to have to record those then. And then another one would be power poles or telecom poles. So see if you can identify those features as well. So the purpose of this is we'll be conducting not only recording these features, but also recording all of the condition of these features in our study area so that we can come up with a little assessment plan. So with the scenario that, let's say a utility company or a city says, all right, here, we need you to go document all the utilities. We need for you to collect an inventory of how good of condition these features are in. So down below here in the next paragraph that I've highlighted, actually, it might be in another one here just below. Let's scroll down here. Here we go. Kind of talked about our collection biases there. So things that we're looking for, what defines a condition? So maybe it's paint peeling off of the feature. Maybe it's a large amount of rust that may be inhibiting the functionality of that particular feature. Some other things, maybe there are branches or a car hit a sign and the sign's bent over. You can't read it, or the lettering is no longer legible to read for someone. Are street lights on, or are they burnt out if they happen to be on during the daylight when you're out there? So those type of things are what you are looking for subjectively related to you. Now, if you're working with someone, you both may want to go out and collect those features together, or if you're kind of dividing and conquering, make sure that you and your partner have a plan for how you are going to define what defines good or poor or kind of moderate. And so I have some categories down here below for how we will rank those. So here are the three ranking categories that I'd like for you try to incorporate for each one of your points. So if, for example, you find a fire hydrant, you will mark that, you will record your name as the collector and then the condition. So it will be up to you and or your partner to determine what subjectively for you defines a for example, excellent condition. There's no issues. Maybe the paint's all good, it's fully functional, it's operational as it is. Now, maybe a category 2 for that fire hydrant would be, you know what? Hey, it's acceptable, everything's functioning. Yeah, there's a little bit of rust that might need to be touched up, or yeah, there's some groundwork around the fire hydrant that there might be weeds or some branches lying around that needs to be cleared away, or something like that, but otherwise generally acceptable. So that might be a 2. And a 1, for example, would be poor condition. So maybe there are parts falling off or parts missing off of that fire hydrant, or the street sign is knocked over, or you just cannot read it anymore, read the lettering. Those would be examples of a poor condition. But think about what that means to you, what those conditions mean to you. And again, we kind of tried to give you some examples up here of what that might mean. This is a kind of a bare minimum, but again, if you were working with a larger group, we would want to make sure that our process for how we are evaluating that rank is super consistent. In other words, they're standardized, that there's a reason for why you are calling something a 3 and not a 2. So we're trying to get you thinking a little bit about that in this particular lab as well. So in any case, you'll want to document in your lab write-up, what exactly did you call a 3 or a 2 or a 1? I know I gave you some categories there, but maybe you want to discuss that a little bit further. So you may also wish to capture photos of your features for documentation. And part of those photos can give you another way to go back and reference or provide rationale for what you recorded and why. So what you are actually providing an assessment for will be just your own individual data. You will not have to worry about looking at other people's data. That's why I'm trying to suggest that you get a robust or a large enough pool of data so that you have the ability to see all the utility features individually parsed out, like all the fire hydrants, all the street signs, all the storm drains, what condition are all of those in, and then collectively together, maybe you find that there's a particular area of your study region that you're in, that all of the features are maybe ones or twos, and that could be an indication that maybe this part of your map or your study area really needs some work. Those utility features need to be updated. And maybe on the other side of your study area, all the features happen to be new and completely functional. They're all in good shape. So from a visual perspective, this could give utility planners a really good idea of where to focus energies each year to make sure that the utilities are optimally addressed and making sure that they're fully functional each year. So that's kind of what we're talking about in this area here for you. So these are all hypotheticals, just trying to give you a mock-up situation that if this occurred, what are the big things we want to think about? One, how are we coding our data? Ranking it. And then secondly, how can we share this story out? In other words, begin to organize the data a little bit and be creative with how you want to share your findings and outline what it was that you found using, again, just your data. Now, if anybody has any problems, you could use some of my data, and we'll address that here in the second integrity video. But I would like to also note that for me on campus here, when I was collecting some points, I would really need to go up myself and do a much more integrated job at making sure I collect a lot more features. I think I had maybe 20 or 30 or something like that on points, but really to get maybe collect a lot more fire hydrants or to collect a lot more light poles so that I can collectively examine what's happening as a whole between all of those features, not just one here and, oh, I'll skip a couple and maybe go to another one, but let's look at that entire cluster of fire hydrants that are in your study area. Let's look at the entire cluster of light poles that you're looking at in your study area and the entire cluster of storm drains so that you can see how all of them relate that are either good condition, moderate, okay condition, or really, really poor. So you'll see some of the output parameters here. And uh, I mean, this is really not going to change in terms of the style or the format. We'll still have an introduction of methods, results, discussion, so on and so forth. But you can share your output in a lot of different ways. It could be graphically like you're used to. If you want to, I encourage you to think about maybe you're using pie charts or bar charts or something to showcase how many of your fire hydrants had a score of 3 versus street signs, which were maybe scores of a 2 or 1, that type of a thing. So I want you to feel like you have the creative capacity to do those things, to share your story using some different visualization techniques, depending on your experience level. But other things to always consider will be our errors. What type of errors? Obviously, we're going to have some horizontal error. That's been a big theme with our GPS as of late. Horizontal error and, of course, vertical. But we're not so much worried about our elevation in this lab. Although, if you are a little bit more experienced and would like to come back through and create an elevation field in your attributes and create your or calculate your geometry for that Z field, you should be able to do that like we did last week. So I'll leave that up to you. If that's something scalable and you want to add, you can do that and incorporate that somehow into your lab. And so the rest of the goodies are provided here, infographics if you want to do something like that. And largely just an investigation of what you found. So think of this as a descriptive analysis. It does not have to be something hardcore spatial analysis. Not that we did that a lot last week for our elevation map, but that incorporated a lot more spatial investigation, where this is going to be a little bit more descriptive, looking at the number of points that were poor, the number that were really, really good, maybe, and then where are they? And how do we want to categorize areas in our map that maybe aren't so good or that are good? for inventorying purposes. So we'll see where we're at next week for that. But I'll be coming back here shortly and giving you a brief overview of the lab itself in just a few minutes. But otherwise, that should take us through a light welcome there and really an introduction to our week 6. So if anyone has any questions on any of this for week 6, feel free to reach out and I'll do my best to help you out. Otherwise, we'll be back soon. And otherwise, we'll see you next week for sure, unless we have an online help session here coming up later this week. So thank you and have a good rest of the week, everyone.